Hello everyone. Last day we discussed about the difference between microprocessor and microcontroller. Today we are going to discuss about the first microcontroller which was fabricated by Intel Corporation. The first microcontroller, Intel 8051, which was fabricated by Intel Corporation, the very famous company. Let's see the specification of this first microcontroller. It was fabricated in a DIP package, dual inline package, and have 40 pins. 40 pins. It has an 8-bit CPU. 8-bit CPU. It can process 8-bit at a time. That's why it is called an 8-bit CPU. It have 128 bytes of RAM. A less amount of RAM is there, 128 bytes, and 4 kilobytes of ROM. 4 kilobytes of read-only memory. The RAM is called data memory and the ROM is called program memory. What is the difference between data memory and program memory? During the execution, the temporary data and the data which is going to execute is stored in RAM, random access memory, and the program, the codes are stored in the ROM, 4 kilobytes of ROM. This microcontroller can be programmed in assembly language or in high-level language by using different softwares. After programming this microcontroller, we can burn that program as a hexadecimal code in the binary format to the microcontroller using a burner. So these are the main specifications, and let's see further more. And it having two timers, one serial communication port, four parallel communication port, these parallel communication port having 8 bits, 8-bit port. So a total of 32 I/O lines can be achieved using this microcontroller. 4 parallel input-output port, each port having 8 bit of data lines, and a total of 32 input-output lines we can achieve using this microcontroller. It will work on 5 volt. It will work on positive 5 volt supply. These are the main specification of a 8051 microcontroller. Now let's see the block diagram representation of an 8051, and we will see what are the internal components inside this 8051. This is the block diagram representation of the Intel 8051 microcontroller. there is a CPU, an arithmetic and logical unit, which can perform arithmetic operation as well as logical operation. It is an 8-bit CPU. It is an 8-bit CPU. What does it mean it is an 8-bit CPU? It can perform operations like arithmetic operation like addition, subtraction, multiplication and division, logical operation like OR, XOR, and this 8-bit operation can perform at a time. So that's why this CPU is called an 8-bit CPU. An 8-bit CPU is here, which was powered by an oscillator unit, oscillator block diagram, which can provide oscillations or clock signals for operating CPU. An external crystal was connected to the oscillator section. Then the oscillator section will oscillate according to the frequency of the crystal oscillator. Then an external interrupt control unit was present in this architecture, which can control the external interrupt operations. We have two external interrupts, external interrupt 0 and external interrupt 1. This operation can be controlled using this external interrupt control unit. Moving further, there is a ROM, read-only memory, and it was also known as code memory, having a size of 4 kilobytes. The program was stored in this ROM memory, and the size of the ROM is 4 kilobytes. And again there is a memory RAM, random access memory, which has a size of 128 bytes. 128 bytes, which can store the temporary data and the data to be processed during the operation. There is a bus control unit. The operation of the bus was controlled using this unit because of this architecture is a CISC architecture, so that a single bus was shared by ROM, RAM, input output port, serial port, and all the functions inside the microcontroller was using this only single bus. That's why bus management is a Herculean task in this microcontroller. So a bus control unit is present inside this architecture. And again there is an input output port. There is 4 input output ports, which was named P0, P1, P2 and P3. Each ports are 8-bit ports. Each ports are 8-bit ports. This was 8-bit. So a total of 32 input output lines present in this architecture. And there is a serial port. We can use serial communication through using this microcontroller. And there is a serial communication port and having a transmit data and a receive data pins there. This architecture uses UART communication. That means universal asynchronous communication was developed, present in this architecture. And again there is a timer unit. There is two timers, two 16-bit timers, timer 0 and timer 1, which can control by software and by externally can control by hardware that can be programmed in this microcontroller. This is the overall structure of a 8051 microcontroller. Thank you.